Oh, and good morning, everybody. We are almost done. So really, literally, this is it. This last week I'm going to teach. Friday we'll have our last test, and then Monday, Tuesday, Wednesday is just get caught up. So if you are done, if you're caught up, you are awesome. Let's just get it done, okay? Still waiting on Chapter 8 from some of you guys. I'm going to send out some emails to parents today to let them know, hey, I don't have this done. So let's get her done, and then we can enjoy vacation. Hoo-hoo, yeah, okay. So let's take a look. First of all, trigonometry is like super important. If you don't learn it, then doggone it, it's going to set you behind. But you guys are getting it, aren't you? Because it's not that hard. Homework. Here we go. So, number one, tangent R is 45 over 24. Tangent of S is 24 over 45. Tangent J is 7 over 5. Tangent of L is going to be 5 over 7. Tangent of A is 2 over the square root of 2, but if you rationalize it, which we should, it's going to be square root of 2 over 2. Tangent C is square root of 2 over 2. 4 is a 28.4 after you set up tangent of 10. 5 is going to be 26.7 after you set up tangent 64. 6 is going to be 39.9 if you set up tangent of 31. If you make a little triangle on this one, you'll see, boom, 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 that you got, this is 3 over 4, but the other angle is going to be 4 over 3. On this story problem, okay, set up tangent of 40, okay, and you get it to be about 83.9, but then if you change the angle, it's tangent of 51, and makes the distance a little bit less. On number 8, here's the boy, and this is 300 here. 300, and use the tangent, so it's 300. This one's pretty complicated, but I'll go through it real quickly. So for those who did it. So first of all, I found this side using tangent, 12.3. Okay, then I used Pythagorean's theorem, and I went 12.3 squared plus a squared equals c squared. Pythagorean's theorem on that triangle. And since these two are equal, I cut it in half. So I knew that this side then was going to be a 7.3. So then I used tangent of 64 with 7.3, and I got this side. Okay, and then I used Pythagorean's theorem to get the 16.7, and I added all the way around. That is a hard problem. I liked it. It was fun. Okay, moving on to today's lesson. If we were in my classroom, which we're not, which is a real bummer, but if we were in my classroom, you'd see up on the board right above me, you'd see sine, cosine, and tangent, okay? So the abbreviations are sin, but it really means sine. You'll see cos, but it really means cosine. And even on your calculator, you can see the sine, cosine, and tangent. So we're going to use all three today. And of course, we saw tangent of theta. Okay. Now, what we haven't been doing is we haven't been using the hypotenuse yet. Okay. Okay. So our objective today is solving right triangles with trigonometry. Trigonometry sounds so hard, but it's really not. Okay, so let's put theta right there. Okay, so if our angle's sitting there, then what we're going to find out is that if this is our angle, we're sitting here, we can throw our stone to the very opposite side, right? This big lake. So you throw your ball, your rock to the opposite. This would be my opposite side. This is my adjacent side because it's next to me. And this longer side, opposite 90, is called the hypotenuse, okay? So, what is sine? Sine is going to use the hypotenuse, but sine is the ratio of the opposite side over the hypotenuse. Easy. Cosine is the adjacent side over the hypotenuse. And we already know that tangent, we learned this from yesterday, well, Friday, is the opposite of the adjacent. So how do you know which one to use? I'll give you a second to get caught up, okay? For the adjacent, so we learned yesterday, okay? How do you know which one to use? It all depends on what you're given. Let me give you 3 different examples, okay? Let's say this is 64 degrees. Let's say this is x, and let's say this is 10. I'll make it a right angle. Well, that's my opposite side, right? That's my opposite side. And that's my hypotenuse. If these are the two things I am working with, this is my opposite side, and I know my hypotenuse, I would use sine. Let me show you a second example. Say that this angle is 21 degrees. Okay. This is x, and this side is 12. Okay. From this angle, this is my adjacent side. It's next to it, adjacent. And this is again my hypotenuse. It's along the side. So in this case, I'm working with these two sides, my adjacent side, which is the side next to my angle, and my hypotenuse. So what about this example? So we always go to the angle first. The angle tells us what we're going to do. So if I go to my angle, let's say this angle is, I'm going to get, how about 61 degrees? And let's say this is 12, and this is x, okay? So you go to your angle, and then you name your sides. So you go to angle, that's my opposite, and that's my adjacent. I would use tangent, okay? So, let's do the first example. And this is on your test. It's really quite easy, okay? Write each of the trig ratios from angle A and angle B. So let's first start with angle A. So if I start with angle A, okay, and if I'm at angle A, then my 4 is my opposite side, my 3 is my adjacent side, and the 5, which is the longest side opposite by 90, is the hypotenuse. So what I want is this. And on the test, I want the same thing. You're going to set up sine of A. Okay? We're not going to solve it. We just want the ratios. Ratio is a fancy word for fraction. Okay? Just want the fraction. What the sine of A? Well, the sine of A is opposite over hypotenuse, so it's 4 over 5. I just want a fraction, or a ratio, okay? I also want on the test on Friday for you to tell me what the cosine of A would be. Well, the cosine would be the adjacent, right, over the hypotenuse, which would be the 3 over 5. And I also want you to do the tangent of A. And the tangent is the opposite over the adjacent, which is going to be my 4 over 3. I want for both angles. I also want for angle B. So now, you're going to walk around the lake, and you're going to go to angle B. Okay, so this has been my triangle A. Walk to the other side. Here's angle B. Now, things change because all of a sudden, this is my opposite side because I walked to the other side of the lake, right? So from angle B, you always go to your angle. That's my opposite side. And now the 4 is my adjacent side, right? Because it's next to me. And the 5, the hypotenuse, is still the hypotenuse. The hypotenuse is always alongside, okay? So if I wanted to then set up my sine of angle B, it's different because B is here. It's going to be 3 over 4. I'm sorry, 3 over 5. Opposite of hypotenuse, 3 over 5. And then the cosine of angle B, cosine is the adjacent, which is my 4 over my 5. And finally, the tangent of B, the tangent's got to be the opposite of the adjacent, which is the 3 over 4. Hopefully you can see that there is definitely some kind of a pattern here. The sine of one angle is equal to the cosine of the other. The cosine of one angle is equal to the sine of the other, and the tangents are just the reciprocals of each other, okay? Now, let's turn the page. Let's see, where would anybody ever use this? Like, all over the place. This is actually used in this real world. So, here we go. Use the tangent to solve the triangles. Okay, so let's go ahead and, why do I say tangent? Well, here's my angle. Okay, so here's my angle. I want to find BC. BC, let's just call little a because it's opposite angle A. Alright, so that's my opposite side. The 12 is my adjacent, right? Opposite adjacent, opposite adjacent. Let's see my notes. If I had my board up above, opposite adjacent, just say opposite. Here, I'll make it look better, like opposite. There we go. Opposite adjacent, which one of these three has a B? Opposite adjacent, it's got a tangent. So we'll set up tangent of theta. Now remember, theta is my angle. Tangent of theta, or tangent of 36, is equal to the opposite. Yes, opposite or adjacent, right? So it's equal to my A over my 12. Okay. So now, what am I going to do? Well, multiply up the 12, right? Times by 12, times by 12, and I'm going to get whatever my calculator says, 12 times tangent of 36 equals A. And again, you can use your phone, but your calculator works. If you have a calculator, the calculator works better. You can even get this on a computer. You can. 12, but make sure you're in the right mode. Tangent of 36, and I can answer about 8.7. If you don't get that answer, you can check your mode, and if you're in radian mode, that's not good. You want to be degree mode, okay? We won't do radians until next year. So you have about 8.7 centimeters. There you go. Okay, now, if I wanted to find GP, in this case, GP is this side, okay? I'm going to go ahead and call it little I, because GP is also another name of I, but more importantly, I've got my opposite and my adjacent, right? So my opposite is 15, my adjacent is little I, so we'll set up opposite adjacent. Opposite adjacent, which one of it is it? Opposite adjacent, it's got to be tangent. So set up tangent of 42, because that's theta. Theta is my angle. Okay. Tangent of theta, opposite over adjacent. Tangent of 42, opposite, which is 15, over adjacent, which is my GP or little I. Now again, yesterday we talked, or Monday we talked about this. If you multiply it by I, the I comes up, and you get I times the tangent of 42 equals 15. And then if you divide by tangent of 42, which is a number, you'll get I equals whatever this is. Well, you need a calculator to do that, don't you? So, alright, what is 15 divided by tangent of 42? And I get an answer of about 16.66. Okay. Alright, I'm going to skip this one because I want to do one out of your journal that deals with sine or cosine. So let's shift gears, and I'm going to go straight to your journal. I'm going to go to page 95. Alright, let's do one of these, okay? Let's do this. Let's work on this story problem together, okay? Last but not least, let's do the story. A camera is attached to a kite filming the damage caused by a brush fire in a closed-off area. The camera is directly above the center of the closed-off area. So let's put, okay, a person is standing 100 feet away from the center closed-off area. The angle of depression for a person flying the kite. How long is the string? Okay, so we got a kite up here, right? Angle of depression. Angle of depression, that's 25 degrees here. Here's your angle of depression. So the angle that goes down is 25 degrees here. And we know that the person is 100 feet standing away, so 100 feet like that. And we want to know how long is the string. Well, that's this right here, x, okay, the string. Now, 25 degrees here is also 25 degrees here. That has to be 90 because it's directly straight up and down. What we're looking for is the string. Now that is, if I take a look at my triangle, okay, here's my triangle, right? Let's label the sides. That's my adjacent side. That's my hypotenuse. Let's see, where's my notes? Adjacent hypotenuse, adjacent hypotenuse. Adjacent hypotenuse, I'm going to use cosine. So we're going to set cosine of theta. Remember, theta is the angle. Theta is 25 degrees. So I'm going to go cosine, right? Cosine of 25 is equal to, let's see, cosine is the adjacent over the hypotenuse. Adjacent over the hypotenuse. So it's going to be the adjacent, which is 100, over the hypotenuse, which we called x. Okay, again, how do we solve for x? We have to bring it up. So we multiply by x, but then we can divide by cosine of 25. Let's do this in one step. We would bring the x up, right? We'd multiply by x, bring the x up. We divide by cosine of 25, so x is equal to 100 divided by cosine of 25. And then I would just use my calculator to get the answer. Let's see, here's my calculator sign right there. 100 divided by cosine of 25. I get an answer of about 110.34. 110.34 feet? Yeah, feet. There you go. Okay, so here's what I want for you guys. I did part of it. But homework today, I want you to page 303. Okay, page 303. You're going to do 1 through 14 all. Okay, all the way to 14. 14 all for homework. Okay, get everything in, please. We're almost done. Really, Friday's it unless you're behind. Okay, so here we go. See you tomorrow.